Okie doke, I've had my lunch and I'm back on to this fabulous surface area. Now we're looking at the effect of surface area on the rate of reaction. And I'm going to model it here with some bars of chocolate and some hot chocolate powder. Now this is a bar of chocolate. If I put it near the flame, it would melt. There's no big explosion, no reacting with the oxygen or any in the air or anything like that. However, if I sprinkle this into the flame, there would be an explosion. I would ask your teacher to do that because it's good fun. And that's because this powder here, this hot chocolate powder, has much more surface area than these great big bars of chocolate here. And hopefully you'll see why during the process of this thing. Now in the classroom, you'll probably have done this experiment. You've either done it where you've weighed the amount of you've recorded the mass of the reactants in here over time as carbon dioxide escapes out of the top of it. Another way here is we've got our marble chips, which are these things here, add acid, and we're going to measure the amount of carbon dioxide given off by collecting it in a gas syringe. So there are different ways of doing it. We repeat that experiment with some marble chip powder. The CaCO3 is the formula, that's calcium carbonate. That is the formula for both of these because they're both the same. One is just a finely ground down. This is the marble, the big one, big marble chips. If I plotted over time how much carbon dioxide was produced, I would end up with a line like this for our large chips. If I then got rid of all the acid and the large marble chips, and I replaced the acid and then added the powder, I would get a graph like this. Fabulous. Now that graph there, this line here, shows that the small marble chips, or the marble powder, produce carbon dioxide a lot quicker than the large chips. You can see here that they end at the same point, and that's when one of the reactants has run out. Normally the acid has run out, because if you had the marble chips here and you react it with acid and it stops producing any more gas, you can still see the marble chips, therefore the acid has run out. So it's stopped, the reaction stops. Let's see why that's the case then. Why does the powder go a lot quicker than the large marble chips? Well, it's to do with this surface area. If you imagine this is our marble chip or our chocolate bar, we can see that it's got all these sides here that can react. You've also got the top and the bottom. So all of that can react. So let's say it's a marble chip and we put it with acid. Here the acid particles are hitting the surfaces bong, bong, of the marble chip. Bong, 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 bong. I hope you like the sound effects. Because they cost a lot of money. Bong. So there we go. Fabulous. So that would happen in your large marble chip. And each time they collided and reacted, you would produce some carbon dioxide. Now, if I was to turn this into powder, I would pull these apart. So I'd chop it up. Now, as you can see, hopefully, look at this. Here, we've exposed a new surface. And again, another new surface here. If I go backwards, we can see all the surfaces that have been exposed. All these bits here are now available for the acid to react. And it does. Bonk, 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 bonk. So it's a lot quicker. There is more surfaces, more surface area in the smaller powder or in the chocolate powder than there are in the large bars of chocolate or large marble chips. Some people get very confused about this. The important thing is you've got to compare with like sizes. So if you're going to compare surface area, you can't compare your surface area of your massive bar of chocolate with one bit of powder. You have to compare it with the same volume. So there is our surfaces on this size piece of chocolate or this size marble chip, and then you've got to compare it with the same area, not just one, because one's only got one little tiny bit of surface area. So it's all of them. So you add up the surface area of all the particles and you'll see that the smaller it is, the more surface area. So the larger the surface area, the greater the number of collisions that can happen between the acid and the marble chip. Therefore, the faster the reaction.